Hi guys. I hope that I've set this up in a way that it's actually gonna stream. Because the last few times I've done it, it hasn't. It may not sound like it, but I actually am doing quite well today, health-wise. So I spent some time. Oh, I haven't got the chat open. Okay, I've got the chat open, so let me know if you're here and if I am actually streaming. If not, at least there will be a recording that I can put up, but I hope that this way of doing it is actually working. Okay, so basically I've spent some more time with variable acceleration questions because I want to unpick. Always my aim looking at exam questions is to unpick what makes this difficult. Why? How can a student get to the point where they open the exam paper and read this and yet don't know what to do or make mistakes, or what can we do before that actual paper to get them to the point where that just not can't happen, but is really unlikely to happen. So looking through the variable acceleration questions and thinking about what makes them difficult. Basically, they're all this. They're all just differentiating the displacement to get the velocity, or differentiating the velocity to get the acceleration, or integrating the acceleration to get the velocity, or integrating the velocity to get the displacement. Now that differentiation and integration is simple. First year, pull the power down, take one off, or increase the power, divide by the new power plus c. That's not complicated. Then we get to the thing that the actual solving of the problem, and basically every question is the same, because what else could they possibly ask other than find s at a time that I tell you, or I tell you what s is and then you find the times. So you're subbing in t into v to find out what the velocity is at a certain time, or you're putting the velocity equal to something and then solving to find the times. Same thing with the acceleration. So theoretically, if it's easy to differentiate and to integrate, and if it's obvious what they're asking for, and the equations that we end up with, even if we have to put the v or the s or the a equal to something and then actually solve an equation rather than just subbing in t, it should be fine, right? So how come it's not fine? So the things I touched on yesterday or the day before, the things that I touched on there that I'd picked up already as being things that cause problems for students. One of them is not knowing what instantaneously at rest and changes directions means, how to actually use that. So we talked about the fact that on a VT graph, we've got the bottom of the VT graph, which is all of the motion that's backwards, basically, or downwards, and then positive V, all the motion that's forwards or upwards. Now, if I want to change direction, then I need to go from up here to down here, or vice versa. So somewhere along the way, I have to be at V is 0. And that V is 0 is where the particle is changing direction, or it might not even change direction, it might just be instantaneously at rest. But instantaneously at rest and changes direction, they can both be immediately translated into V equals 0. The other thing that I pointed out is that it's very, very common to see a question that asks for the distance. And when they give you s, in every other question apart from one, there's only one question so far that has said that s is the distance, but they ask you for distance. S is displacement, not distance, and then they ask you for distance. So that was something that I flagged in the last lesson that we looked at, and the fact that, yeah, we are going to integrate the velocity to get the area under the VT graph, which is the distance travelled, but if that graph goes negative, then we need to split our integral up into two bits. The bit that's positive, the bit that's negative, get the negative bit, ignore the negative sign, add them up. That'll give you distance instead of displacement. So that's what we talked about last time. And I mentioned that there were these unknowns as well, and that a lot of the time what they're doing in these questions is they're giving you information and they're expecting you to use that information to find something that we don't know, a letter, K, A, B, C, P, Q, whatever. So that is in there as well, and it's not something that we would include when we were, as teachers, were teaching it. Then you teach all about how do you get from S to V or V to A or back in the other direction and that sort of thing. Whereas actually I think what makes these questions difficult is just how much of these unknowns there are. Now they come in two ways. One way to introduce an unknown is literally just to put it in the equation. So V equals t squared plus AT plus B, and I don't tell you what A and B are. That's one way to introduce an unknown. Then I've got to give you some information that you can use to find the unknowns. Or the other way that it comes in is naturally when we integrate. So when we go from A to V or V to S, we introduce a plus C. We need some information to find the C. So there's lots of information hidden in these questions that is difficult to spot, and even knowing what that information is for, even if you spot the information, can be difficult. But I noticed another thing as well that examiners are doing, and it's an extension of the thing that I was talking about the other day, this one, the fact that they're giving you an equation for the displacement or the velocity, but asking you to find the distance, and it's an extension of that. So here's the example that we already talked about: distance, displacement, recognizing the difference. They can also do it with speed and velocity, which is the same thing really. Do we want the magnitude of the velocity, which is the speed? Do we not care whether it's going forwards or backwards? Or do we care whether it's going forwards or backwards, so then we'd need to include the plus or the minus? So if the question asks for speed, it's always going to be a positive not a whole number, that's rubbish, a positive number, whereas if we're asked for velocity, then strictly speaking, that should have a direction on it, a plus or a minus. With acceleration, we don't have this other word. So we have distance and displacement, we have velocity and speed. I don't know if I did those the right way around. And then the vector version of acceleration is acceleration, and the magnitude of the acceleration is called acceleration. So the way that they can spice it up a bit with the acceleration is to talk about acceleration, deceleration, and the magnitude of the acceleration. So just by using different words there and linking you to either, we want to know just the magnitude of the acceleration. We don't care whether it's accelerating forward or accelerating backwards, i.e. don't care if it's speeding up or slowing down, but just by how many meters per second. So this is one of the big trip hazards. I think the big trip hazards are, I'll show you here, I've listed them. How do they make it so difficult? The first one is what I was talking about, where they change the way that they describe the thing they want you to find or use. So instead of saying find the displacement at time t, they say find the distance travelled up to a certain time. Or instead of saying find the times when the velocity is this, they might say find the times when the speed is this, or find the speed at time t. Find the deceleration, or find the times when the deceleration is, or find the magnitude of the acceleration. So what they're doing in number one examiner tactic is to go in and change the words that they're using for displacement, velocity and acceleration. Number two trick that they use pretty much every time, I'll do this one in blue, is to put a question inside a question. Apparently I won't do in blue because the pencil's not working. They put a question inside a question. So instead of saying find the velocity at time t, they will hide this question inside that question. So they'll say find the velocity at the time when the particle is accelerating at 2 meters per second squared. Now that makes the question a lot longer and a lot more confusing, because it's saying find the velocity, then it's mentioning the acceleration and the time, and they could also hide that piece of information further up in the question, and you could have to look all around for what you're meant to be doing. So a question, one of those 6, picked up and put inside another question, so it's not explicit, but you have to solve the inner question in order to solve the main question. That's very, very common. And then the third sort of examiner trick or examiner hazard that they can put in for you is all of these unknowns. So they can put unknowns in the S or the V or the A, the thing they give you, and as well as that, they know that if they force you to integrate, so if they give you A and then ask for V or S, or they give you V and ask for S, then they know that you're going to pick up a plus C. Now they've got to give you the information so that you can find the C, so they've got to give you when T is this, V is this, or if you're integrating and getting S, when T is this, S is this. But they don't have to give it to you in that obvious way. They can put it up in the introduction. They can again use different words for the S and the V and the A, and they can put the piece of information in the middle of a sentence or at the beginning of a sentence, at the beginning of the whole question. They can hide that information that they're giving you, and they're giving you that information so that you can find the unknown that you need. So it's a type of question in question, really. In order to solve the actual question that they're asking, you need to find the value of the unknown. In order to find the value of the unknown, you need to recognize the information that you can use to find the unknown. Okay, so we're looking out for confusing the issue with the way that they describe S or V or A, question inside question, and unknowns that we need to find because we've had to integrate or because they were in the question. So when we go back through these and have a look at them, what I'd like to do is to get a bunch of you together who are working on this, and we'll go through these questions together slowly, carefully, and see where those issues come up. So I'm not going to do all of these today, but I'm just going to, sorry, hang on. I am just going to highlight to you where those bits of information are in the question in question. So here's an example of a question in a question. Find T when, oh no, this one's just a question. Find T when S is 0. So it's literally just S is 0, find the times. The reason that that's more difficult is that we don't know what S is in the question. We're given V, not S. So in order to get from V to S, we have to integrate. Integrating picks up a plus C. In order to then put that S equal to 0 and solve, we need to know what that plus C is. So somewhere there must be the information that we can use to get the plus C. Now if you have a look up here, this is where they hid it, the information. And they hid it really well because they hid it right at the top of the question, not down here, which is where we actually need it. And they combined 2 pieces of information into one little half sentence. And one of those pieces of information we already even knew. So that further disguises the other piece of information because it looks like just, you know, the blah, blah, blah of a question. A particle is going in a straight line, does this, blah, 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 blah. You know, the bit that you don't have to read, basically. So when they say initially, that means T is 0. You'll see that a lot in modelling questions and differential equations as well. Initially, T is 0. And then they tell us 2 things about when T is 0. They say when T is 0, V is 0. That's the at rest. V is 0. And then they also tell us that when T is 0, we're at the point 0. We're at the origin. So this little bit here says when T is 0, V is 0. Now look, we already knew that. Well, I guess we didn't. I guess you could say, strictly speaking, we didn't. Because if you put T as 0 in here, yes, you get V as 0, but then you go, oh, look, though, that's only true for T greater than 0. So if T equals 0, we have no idea what V is. I guess you could argue that. That would be fair enough. So here's our pieces of information that we're going to use down here. We're going to integrate. We're going to pick up an unknown. We're going to use this information to find the unknown. Now we know the equation, so we can put the equation equal to 0 and then solve to find T. Now this is a nice question to show you as well, to remind you of this lovely little rule, which is that if they mention the mass, then they want you to use F equals ma. And if it doesn't mention the mass, or it's not about forces and it doesn't say equilibrium, those are the only two things that mean that you need to use F equals ma. One of them is that they mention mass, and the other one is that it says equilibrium and it mentions forces. Because then the acceleration is 0, so you can still use F equals ma and use your forces, but the right hand side is 0. And so that means we're definitely going to be using F equals ma. They ask us for the force. Now the acceleration is going to have t's in it, variable acceleration. So this is going to have t's in. Mass doesn't have t's in, it's not a variable mass, it's mass 400 grams. The force that comes out will have t's in, and that's okay. F equals ma works with variable acceleration, vector acceleration, constant acceleration in one dimension. F equals ma is still true, it's still fine. So in order to find the force, we need the mass and the acceleration. They tell us the mass, they don't tell us the acceleration, but we can differentiate the velocity to get the acceleration, so that's all good. There is an examiner trick here. And they're trying to make these questions difficult, right? Because they're not difficult, they're fundamentally not difficult. They are fundamentally just these things here, and F equals ma is just stick in the bits you know and then get the other bit that you don't know. So the examiner trick that they've used here is not the right unit. It's not kilograms, it's grams. So they've set this up so that people will put 400, not there. No one would put 400 there, that would be silly. People put 400 here and it's not 400. Because when we use F equals ma, we're using the standard units, the same as when we do SUVAT, meters, seconds, newtons for force, kilograms for the mass, meters per second squared for the acceleration. So little ICU examiner in there on the units. Okay, let's have a look at another one. Although, as I said, I don't want to look at loads today, I just wanted to show you that structure that I'd noticed. And then, as I say, I'll get a bunch of you together and we'll do it in a session just working through them. I'm hoping it'll really help sort this topic out. Okay, they've given us S. Now this is the one that I told you about. They've described it as the distance of the bird from the nest. The distance, not, and it's the distance from the nest, not the distance it has flown, but the distance from the nest, which is displacement. So the one question where it says distance, actually it's displacement, because if the bird flies away and then flies back, then when it gets back, S is 0, displacement is 0, but it has flown, it has gone a distance, and we could try to find that distance. Indeed. Oh no, look, find the distance of the bird from the nest. So that's the displacement, so that's okay, that's this, which is the distance of the bird from the nest. So that's all okay. Right. Find the distance, so they're asking us to find S, but they're not telling us the time. So this is a question inside a question. They're telling us that we want to find this at this point where we're at instantaneous rest, which, as we mentioned, is where V is 0. So we have to solve V is 0 to get T. Then that T feeds into S, which we are given, and then we know what that distance is. I don't know why it's 6 marks. I'm not going to go through it now, but I'll go through it with a couple of students. Okay, no, it's bothering me. So the bird leaves the nest. What I'm wanting to do, and I know this wouldn't occur to most normal humans, but I want to know what this looks like, this displacement time graph, so that I can picture what this bird is actually doing. So let's think. It is a quartic which means it looks like this. It's positive quartic, which means it looks like that, but it might have a little wibbles in the middle because it's got a cubic turn and a quadratic, so maybe it looks something a bit like that. It's got a double root at the origin because it's got a common factor of t squared. So if I pull out that t squared, you can see that double root at the beginning, double root at 0. So it could be that there's a minimum point at 0, that would be a double root 0. It could be that there's a maximum point at 0, that would also be a double root at 0. I'm guessing it's going to be that second minimum point, and then it will go like, no, because then the bird just flies away. The whole point is that this is displacement, really, it's how far it is from the nest. And we are told that it goes on its flight and then it returns to the nest. So when it says returns to the nest, that's another time when the distance from the nest is 0. So the bird is in the nest, S is 0, flies away, S is getting bigger and bigger and bigger, and then it turns round. So V is 0, so instantaneously at rest, it's going from the top of the VT graph to the bottom of the VT graph, turns round, comes back, S, which is the distance from the nest, starts getting smaller and smaller and smaller. Now the only bit of that quartic graph that behaves in that way, that the displacement or the distance from the nest gets bigger and bigger and then smaller and smaller, is that middle bit of graph. So I could do a bit more thought, but I think it's going to be something like that, and that this, I'm guessing, is going to be 10. It's going to be 10. And the reason I'm guessing that that's going to be 10 is that the bird leaves the nest, S is 0, flies away, instantaneously at rest. The gradient of the ST graph is 0, meaning V is 0, and that's because it's going from the top of the VT graph to the bottom of the VT graph. And now it's getting closer and closer and closer to the nest, and now it's back at the nest. So I would guess that that bit there is 10, but to check it, I would have to stick 10 in there and see that it came out with 0. So now it makes more sense to me what we're doing. We need to, when the first bird first comes to instantaneous rest is here. So in order to find that, we need to solve V is 0. In order to solve V is 0, we need to actually differentiate. So you've got the marks for differentiating, then the marks for putting it equal to V equal to 0 and solving that equation to get T. Then you put that T into the S, and then maybe a mark for units. Now it makes sense how many marks it is. So the red bits are where they're hiding the information. In this one, the information was that S is 0 at T is 0, and that S is 0 at another time in the future. Okay, I will leave it there because I don't want to be making stupidly long videos, and I will email you all and we'll set up a time. And what I think would be good is for us to work through these together, and then as the queries come up, as you start thinking, oh hang on a minute, how would I know to do that, or what does that bit mean, then that will help your understanding, and also it will help me to see where maybe there's still little threads of confusion or little threads of examiner trickery that we can unpick and unthread from the questions, because they are very wordy. Look, all of these VT graph questions, they've got lots and lots of words. It's not like, you know, just integrate this. There's too many words. Okay, I hope that was helpful.